Non-functional requirements, or NFRs, define how a system should behave rather than what it should do. While functional requirements describe features and capabilities, NFRs focus on qualities such as performance, security, scalability, usability, reliability, and maintainability. When viewed from a solution and design perspective, NFRs become powerful drivers of architectural decisions. They influence technology choices, integration patterns, infrastructure setup, and overall system structure. One major benefit of NFRs in solution design is architectural clarity. When performance, availability, and scalability expectations are clearly defined early, architects can design the system appropriately. For example, if high availability is required, the solution may include redundancy, clustering, or multi-region deployment. Without defined NFRs, teams risk building a solution that fails under real-world conditions. NFRs also reduce costly redesign. Many design problems emerge late in development because quality expectations were not considered up front. If performance requirements are discovered after implementation, teams may need to re-architect core components. By defining NFRs early, architects design with constraints in mind, preventing expensive rework and technical debt. Another benefit is better technology selection. Non-functional requirements, or NFRs, guide decisions about databases, cloud platforms, frameworks, and integration tools. For instance, if a system requires real-time processing, it may demand event-driven architecture and low-latency databases. Security requirements might lead to zero-trust models or encrypted communication protocols. So, NFRs really ensure that technology choices align with business expectations. Reliability and resilience are strengthened through NFRs. Clear availability and fault tolerance requirements lead to design patterns such as circuit breakers, retries, load balancing, and disaster recovery planning. These design elements make systems more robust and reduce downtime risks. As a result, the solution becomes more stable in production environments. So, security-focused non-functional requirements, or NFRs, actually have a pretty big impact on solution architecture. Requirements for things like authentication, authorization, encryption, data protection, and compliance all play a role in shaping system boundaries and access controls. Designing with security in mind from the very beginning really helps prevent vulnerabilities and supports regulatory compliance, like GDPR or industry-specific standards. Maintainability is another major design benefit. When non-functional requirements include code quality, modularity, and documentation standards, architects prioritize clean layering, separation of concerns, and loosely coupled components. This leads to systems that are just easier to modify, extend, and support over time. Good design really does reduce long-term maintenance costs. Usability non-functional requirements enhance user-centered design. Performance response times, accessibility standards, and user experience expectations guide front-end architecture and API design. A system designed with usability requirements in mind results in higher user adoption and satisfaction. Solution design becomes aligned not just with technical needs, but also with human interaction. Non-functional requirements also improve integration design. Interoperability and compatibility requirements determine API standards, messaging formats, and integration patterns. When these are defined early, architects design consistent interfaces and ensure smoother communication between systems. This really reduces integration complexity and future migration challenges. Finally, non-functional requirements align solution design with business strategy. They translate business expectations, such as growth, reliability, compliance, and customer trust, into measurable design constraints. By embedding non-functional requirements into architecture decisions, organizations build solutions that are not only functional, but sustainable, secure, and scalable. In essence, strong non-functional requirements turn architecture from reactive problem-solving into proactive, value-driven design.